Hi all, thanks for joining this morning for our series of gnarly data waves from Dremio. My name is Maeve Donovan and I will be introducing the webinar today and our great speakers on the topic of From Startup to Scale, how ForceMetrics revolutionizes police data with Dremio. We have a really exciting conversation today, so we'll go ahead and dive right in. I do want to highlight we do have the Q&A button, so please feel free to go ahead and throw any questions you have as we have our speakers presenting throughout the presentation, and we will go through at the end and answer any of these questions. Great. With that, let's go ahead and go through our agenda today. We'll go through our introductions and introduce you to the great team from ForceMetrics, who will then chat about ForceMetrics as a business and also go through their business challenges and requirements, what their technical implementation looked like with Dremio, and what benefits and business impact they saw. They'll wrap up with some key learnings, and then we'll go through some Q&A like I mentioned previously. So our speakers today, like I said, I am Maeve Donovan. I am product marketing here at Dremio. We also have Austin and Brendan from ForceMetrics, and I'm going to open it up so that they can both introduce themselves properly. Austin, Brendan.
Hey, thank you. So thanks everyone for attending today. So I'm Brendan Cronin, co-founder and head of engineering and ForceMetrics, and come from a kind of wild background of building and breaking software and infrastructure.
Yeah, good morning, everyone. I'm Austin Hervius, DevSecOps engineer here at ForceMetrics. Been here for almost 4 years now, building infrastructure and data pipelines, as well as security as a whole. So doing a little bit of everything, which is always nice.
Yeah, so a little bit about ForceMetrics. So ForceMetrics, we're founded in 2020, and we're a GovTech startup that helps first responders find and understand valuable information faster. So what we do is we provide a modern web app with a single search bar, and we allow our users to search tens of millions of records, really in milliseconds, to quickly surface insights that help them better understand situations that they walk into every day. So the challenge in the space is a bit of a unique one because the public and Hollywood largely overestimate a lot of the technology in policing. So you've got a lot of different legacy systems where there's all sorts of different terminology and meaning and data structures and different logical relationships. There are a lot of inconsistencies in the data. And all of these systems really were designed as a giant data entry operation is the easiest way to think about it. So never were they originally designed up front to actually make searching easier or surfacing information easy or performantly interacting with the system in general. So it you get a lot of the garbage in, garbage out sort of issues in this space because on the far left, those screenshots there, that's what most of policing looks like. And then in the middle, you've got, that's actually one of our customers. It's a real-time crime center, which is definitely a much more advanced view and impressive view, which is closer to the far right, which is what Hollywood typically depicts everything as, zoom in on the license plate from 2 miles away with a ATM camera kind of thing. That's not really the way any of this works. But so there are a lot of security requirements that come with this because at the end of the day, all these systems have a lot of criminal information in them. And really because the systems are so old and so difficult to interact with in general, and there's so many different systems, there's a large appetite to get the Hollywood sort of depiction of policing technology closer to reality. And that's really where we start to augment their experience.
Yeah, as far as data landscape goes, so public safety agencies typically have 2 main systems where data is stored and collected. These are CAD and RMS. So first one, CAD, or computer-aided dispatch, is used by dispatchers and first responders whenever a call is received. So this includes things like the caller's information, any addresses attached to the call, and the notes that the call taker adds to the call as it comes in. That's where that's all stored. If it goes on to become a more serious incident, then that's going to be stored in RMS, or records management system. And that's used by officers and crime analysts to store more granular information related to calls or related to incidents generated from those calls. So this includes officer reports, involvements. So think who is a victim, who is a vendor, arrest information, people records, and vehicle records. And outside of that, there's some other systems as well that include things like geospatial data. So this is something like shapefiles for outlining districts, license plate readers, jail management, and various other data that's received from data brokers.
So requirements, it all comes back to requirements. So how do we actually accomplish this, right? There are a lot of ways to complicate getting data and implementing data pipelines around complicated data. So there's a reason why I put the good Elon Musk quote in the top right, which is question the requirements, delete the part, which is something we really try to live by, which is, the second you've come up with something that you think is a very good implementation, you should always ask yourself next, why does this exist? What can we delete instead of optimize, right? So the requirements are keep it simple. I really should have put that first, but I hope the quote accomplishes that. But then secure by default. I mean, this is criminal data, and everybody who even can view the data, not who does view the data, but who can view the data, has to go through background checks and state level, FBI level, really approval to be able to view that. So we have a lot of security requirements that are unique to the industry, beyond what you would typically find in finance or any other sort of even healthcare, beyond what you would typically find in those industries. So, for instance, if you violate certain security policies, technically it's a felony. So there's beyond business incentive. There's also personal incentive to treat the data with the privacy and respect that it really does deserve, given the context of it. So, in order to not lose track of where the data comes from, one of the really important requirements is that we need a predictable, repeatable, and understandable data lineage, which is a different way of saying anything that we've done to any row of data, we need to easily and constantly be able to assess where did that come from? When did we get it? What was the original value of it? What exactly was the before and after of that change, et cetera, et cetera. So it should be easy, though, to ask any question of our data. So we have to allow our data consumers to learn and extract value without a high amount of friction, but also it should be one of our goals is to make it easy to ask the same questions of really any data, even if it comes from a different customer, a different system, and maybe the same system that they use in a completely different way, et cetera. So in order to accomplish that, another requirement really is to never introduce mystery or magic, which is usually more of a process than a task, but never introduce mystery or magic. You have to keep things obvious and simple. And it's easier to say than to accomplish, but have to keep things obvious. So separating the customer data, really just comes with one of the various security things, but it's also just a best practice of, we can't just pool all of our customer data together, then add a column to it and be like, filter for this customer. It's not good enough. Like, it actually needs to be completely separate and siloed from one another in their own secure enclave, so to speak. But universally analyzable, rigorous change controls, what changed and when, who changed what and when and why, beyond just SOC, just we need a very, very granular level of auditing, because at the end of the day, like, if we misrepresent some data, that's a big problem. Because let's say somebody were to look you up in ForceMetrics, or look up a location in ForceMetrics, or a past event in ForceMetrics, and they get a false understanding of what actually happened or what that person's past involvements entail, then you have a high risk of them creating a complete false narrative for what a situation might entail. So, and then last but certainly not least is it has to be highly scalable. We're a startup, and with startups come exponential growth. Some of that we're experiencing right now, which is a good time. It's a great problem to have, but highly, highly, highly scalable. It's a very important caveat, because as the saying goes, it's always easy. Any problem is easy if it'll fit on your laptop. This does not fit on your laptop. So it has to be highly scalable, however we go about this. So technical implementation, where do we start? Where are we now? Where are we going? This is an intentionally reductive slide because really the main point is early on we were ingesting CSV files from some customers who we didn't yet have an ability to pull data. There's a lot of friction in just the space in general and getting access to data and being able to build out pipelines that actually pull it on a continuous basis. But we were able to get some CSVs. So early on, it started with a pile of CSVs in S3. And that's all we were able to get our hands on. And thankfully that later and quickly evolved into a more standard data ingest pipeline. So leveraging Parquet, Parquet.snappy to be specific. And then later on, instead of just querying folders full of Parquet from Dremio, we adopted Iceberg. And Apache Iceberg is a fantastic technology. Anyone who isn't using it, I highly recommend you play around with it and start using it. And it can be a little bit scary, but it's also actually way easier to get into than you would think. You just have to start that process. So it's a great answer for a lot of the key needs that we had just talked about. So highly performant, very, very performant. I mean, there are people who have petabytes of data and stuff. So it's highly performant, scalable. It offers snapshots, rollbacks, etc. And it's flexible in that it's like relatively agnostic in your choice of underlying storage. So there's people with Microsoft Cloud, there's Google Cloud, there's Amazon, of course, and you could put it in S3 or any other data lake or on your laptop. There's all sorts of ways you can use it. So it's not a tightly knit, like hard to access, like vendor specific space behind a massive paywall or anything like that. Iceberg is a very accessible technology. And did I mention it's fast? It's fast.
It is fast. So as you can see here, this is our current architecture. We perform the ETL operations required for the ForceMetrics platform all in Dremio. The ingest data that we receive from the agencies as Parquet files is stored in S3 and then upserted into the Apache Iceberg tables. Basically from there, then we perform all the necessary data cleaning and preparation. Brendan's going to touch on this a little bit more in the next section. But that all occurs semantically in VDS's downstream of those Iceberg tables. So this means that we never actually directly manipulate the underlying source data, which is helpful for auditing purposes. Outside of Dremio, the data consumers can access the standardized data that we've standardized via Dremio in a variety of visualization tools, including our ForceMetrics platform.
So data flow, as Austin said, you have to accomplish these requirements somehow. So we had to think quite a lot about this up front. Change is friction, but change is also good. So any process, any structure typically comes from constant small iteration. And we've learned a lot through that process over the last 4 years now. It's crazy to think 4 years. And so, yeah, how do we actually accomplish this? So, the progression through Dremio space is a very important topic. So everything at the end of the day, it's sitting in ICE3 and in ICE3 and S3 with Iceberg. ICE3, we're going to coin that term, I think. And because of that, it's queried from Dremio, but semantically represented. So we don't have all these complex pipelines that change data, then move it, and change data, then move it, and change data, then move it, and change it. It's all semantically represented in Dremio. And that's one of the many areas that Dremio really shines here. So we have separated this into really like 3 main spaces is the way to think about it. They'll essentially build on each other. So, you've got cleaned, standardized, and curated. And how do we ensure that we build these out in a way that we allow repeatable patterns, expected ways to find data? Is like, where is this data for this client that's completely different, that comes from a different source system? Where do I find that? There should be an easy and obvious answer to this. So space structure and just maintaining clear data patterns and data lineage is extremely important. So, the clean space, we essentially are just pointed at the Iceberg tables, and more or less you could just think of that as it's nearly identical to those source tables, but any manipulations or improvements or completed lookups that we have to do, which is always different for every table, every system, that's typically where we do it. So you can imagine there's a column in one table. There's really thousands and thousands, but a column in one table that we need to perform a lookup for to go from some crazy format that you would not think these systems use to something that's more like, what's the color of a vehicle? Red. Well, what's red? 0x7B8cc7. Oh, okay, I guess that's red, right? So we do that in the cleaned layer, but we do that by actually not changing that data. We'll essentially prefix the specific field or column with FM, so ForceMetrics. So FM underscore that field name is essentially our post lookup and or slightly manipulated or even created and added and joined or catted field for the given manipulation. So because of that comes standardized, we have the ability to actually standardize calls and incidents and people and all of these different data types, but we have to do that in a predictable way because that's the definition of standardized. So how do you make it so standardized isn't a 4,000 line SQL query that would take you a whole day to understand is part of where cleaned comes in. The clean space comes in to help build off of. So you have a more understandable lineage between what did we change in the source table, what did we actually do to get it into a more standardized form. And because of that, we have the ability to now come up with the curated layer, which is, imagine we wanted to look at all of our customers' incidents or any given data type. We can in the curated space just make a giant union where it's essentially just select star from standardized whatever, because they're all the same shape. So this flow makes it so that we can really leverage the power of Dremio's semantic representation of data while not losing any of the perks of the data lineage that we get through all of the various other things that we do.
And then comes managing all of those VDSs that live in all of those spaces. So with hundreds of source tables and VDSs in the Dremio spaces to manage, we needed a way to implement change management to both preserve the history of the changes and require the approvals for change. So we're using the official DBT Dremio connector to do this. And this allows us to store all of our VDSs as SQL files in a GitHub repo, and then sync the changes from the main branch via DBT whenever the changes are merged into that branch. So this gives us the advantage of the full history of changes made to each VDS and the benefit of being able to roll back easily if a change made didn't work out. And basically all of this results in us being able to process hundreds of millions of source data rows. The average query time is somewhere around less than a second, dozens of unique customer source systems. And this is all occurring per Dremio executor node. So it is super fast as we keep reiterating.
Right. And one thing to add on top of that actually is per Dremio executor node. One thing we should mention is that this is all in Kubernetes. So if we want to expand our current Dremio cluster or clusters, because there happens to be more than one, if we want to expand that to be 10 times the size and cost, 10 times the compute cost and size, and instantly be able to support at least 10 times as much data flowing through it, or 10 times as many users actually querying it constantly, then all we need to do is use a single line and just scale it up. No problem whatsoever. So it unlocks a lot of things. So what are the actual benefits and business impact? Because at the end of the day, everything's a business, including ForceMetrics. And as great as it would be to just have a lot of fun and not need to worry about money, we still need to make sure we're getting an ROI. On everything that we do, we need to make sure that we're being efficient, and that way we're actually still around to provide value in the future, because otherwise it's just reckless, right? So to be responsible with this, we need an ROI. What does that look like, right? So essentially, we've come a long way from Dremio directly querying a folder of similarly-ish shaped CSVs sitting in S3. And now, because things have been growing, let alone our customer base, we actually have a lot of engineering ROI that we could talk about on this. And mainly, you could think about everything comes back to velocity. Velocity matters the most. Like at the end of the day, there's kind of two core things, right? Don't ship low quality stuff and do it faster, Right. So how do you actually get that? And avoiding complex ELT, or rather, sorry, ETL, so extract, transform, load, that's the typical flow. But with Dremio and semantic representation of the data, we're actually more so doing ELT, if you think about it, which is extract from the customer's data source, load it into S3, and then semantically transform it in Dremio. So that inherent deduplication that comes with semantic representation is massive, because most data pipelines end up having to copy and copy and copy and change, and then temporarily store and then delete, et cetera. And you get a lot of, well, assuming you need to maintain the lineage of those changes, a lot of logging challenges that you need to solve for. You have a lot of problems that you need to solve for. But semantic representation means it's just a SQL query looking at data that hasn't changed at all. So we get a lot of benefit from that. And as far as being in engineering goes, you get a lot of morale and confidence boost from that, because Dremio is our data engineer's favorite tool. It's a fantastic tool, but having that absolutely like frictionless experience of like, I want to go and look at where did this row come from? That this client's table, that row. Okay, we got it at this time, and this is how it was, and this is what we changed. Here was the before, here was the after, and experimenting with ideas. That's very liberating, and that's very empowering. If you compare it to a lot of experiences where they're essentially, locked into a system where, okay, let me go and find the source data for this and trace it through the system. That's a day-long process, and with us, it's due to Dremio, it's not certainly not a day. It's more like a minute. So the cost savings and avoidance are massive, because at the end of the day, like, it's a lower lift. So we don't need to hire as many engineers to accomplish the same amount. And as a startup, it's pretty important, because we don't have the kind of budget that a billion-dollar, trillion-dollar company, they're actually trillion-dollar companies now, we don't have those kind of budgets, right? So to be cost efficient and be flexible and have all of our data in S3 and queried in place is a massive, massive benefit to us as a company, and therefore to the amount of value we can actually provide our customers. So reducing the data transfer costs by querying in place and having more efficient storage is really what a lot of this comes back to. And then as far as what the users and what the business actually experiences as a result of that, as cool as that all sounds from the engineering perspective, we get to onboard customers in hours or days, or just depends on the system, on the customer, but we've done it in hours before, end to end, onboarding a customer from nothing to, hey, go and search it in ForceMetrics. And that in most scenarios for our type of business would probably take months or quarters. And there are others in the space that do different things, but have to interact with this kind of data, and it takes them quarters. It's a 6 to 12 month implementation process. So it's very empowering, and we get a lot of business impact from that. So with that, there's some key learnings worth mentioning. So this is a couple good quotes on the left I think I should start with. So the most common error of a smart engineer is to optimize the thing that should not exist. And that's a different version of the quote that I had earlier in the deck here. And really that's a different way of saying that reducing the complexity and deleting the part is something that Dremio actually lets us do. And most softwares, most architectures don't actually empower you to do that. And that comes with overhead. And that ultimately hurts the user, let alone the business, but it actually ultimately hurts the user. So keeping things simple, very important. And don't rationalize data loss, just avoid it altogether. So working with complex, like disparate data sets, you'll typically, let's just say you have 45.8 million rows, and then you do some join to improve it a little bit, or do a lookup or something simple, and you go and look, and there's 45.79999 million rows. Don't rationalize and be like, well, it's close. Go and investigate that. And a tool like Dremio actually allows us to do that with basically no friction. So investigate that. Don't rationalize it as, well, there's a lot of data, maybe it didn't line up perfectly. Well, which ones didn't line up and why? Actually investigate it. So don't rationalize it as like, well, it happens because some things are weird, right? And build a change management process around your VDSs. So, but don't drown in it. So any good process, like I said before, comes out of constant iteration. If you want to, spend 2 weeks coming up with the most complex, like clever process up front, at the end of 2 weeks, you haven't done any work and you haven't learned from any of your mistakes. So build a change management process, but don't drown yourself in it. See what works, see what doesn't. And I think the fourth bullet is the most obvious thing that I shouldn't need to put, but I feel like in our industry, a lot of engineers and a lot of companies just need to be reminded of it, which is fix your pain points. Like they ultimately hurt the business and hurt your users' experience and hurt your velocity as an organization. And you need to be able to make new mistakes. Don't keep making old mistakes and don't keep tolerating pain points. Fix them, move on, and then you'll be amazed what you can do if you just improve 1% a day. In 12 months, that's a lot. I'm not going to do the math, it's too early. But then start from a solid foundation of underlying data, right? So Iceberg really being the main thing here, but start from a solid foundation of underlying data. If you're trying to build the world's most clever product around a terabyte of very poorly organized CSVs, it's not going to go well. So don't pre-optimize, but also, even though 99% of pre-optimization is like the root of all evil or whatever the number for the quote is, that 1% is absolutely critical. So make sure that you actually keep an eye on what is working and what's not, but start from solid foundations, and then everything else will go smoothly. And then there's a bonus key learning I wanted to add in. I should have put a little chart here. So Dremio has a distributed data store that it uses for all sorts of internal workings that if you deploy it in, say, AWS like we do, then it stores everything in an S3 bucket that you assign. So we had a policy early on where every S3 bucket that we create, we had unlimited retention on for every version change because we're like, oh, why not? We didn't have much data. And well, don't do that for something that is used for data that a system accesses and constantly deletes and then creates and then deletes and then updates and then deletes and creates. You would never be looking at that bucket anyway. You don't need to go and inspect what's in that bucket. It's basically a storage that tools like Dremio use, and they can constantly use it, and you don't need to worry about it. Well, if you have versioning enabled for that distributed store bucket, you might find an exponential chart. If you've ever seen something exponential, then this would be a great example of that, because that retention, even if it's a small amount of data, change, slightly more, change it slightly more, change it, like that is exponential growth, and your costs will reflect that. So we at one point started saving a couple $1,000s a month if we actually projected it out more than a month. And if we projected it out about a year, it would have been maybe $15,000 a month or $20,000 a month just in versioning costs in S3 that would provide us no value. So there are plenty of ways to have a stable and secure and recoverable Dremio deployment, which isn't the point of this talk, but the key learning here would be enabling versioning on your distributed store bucket is not one of them. So proactively avoid that cost.
Or at the very least, make your S3 retention policy rather aggressive. Make it something like 3 days in the last 5 versions, not 7 days.
Yeah, or unlimited and unlimited. Yeah. So so I think that covers most of our key learnings. There's some more, but
Awesome. Thank you so much, Brendan and Austin. That was super insightful to hear. We do have a good amount of questions, so thank you all for participating and throwing questions in the chat as we've gone along. We'll try and answer them, grouped together where possible, but also in order of them coming in. One of the first ones we got was from Mark asking, when talking about all of the first responder data, loving to know, how much of the data is, sensor data or video data versus, just pure input in a form.
Yeah, no, good question. The majority of the data from these systems tends to be text-based data. So a lot of police reports that are written, a lot of, just arrival information, who went to a call, when did they actually arrive? What did they do there? What was their role with the call? Did somebody get arrested? Who was arrested? What were they arrested for? Like, this is a lot of text data. There's also a significant amount of video data, but for the majority of our product right now, like, that's not what we focus on, because we focus on search and we focus on enumerating, or rather just surfacing, very difficult to find information buried in their data that might take them days or weeks or hours, depends on the example, to find, let alone understand quickly. And so that's where we focus on mainly. Yeah.
Perfect, thank you. Next question, also from Mark, is do you use Project Nessie in your data flow?
So Austin, I think I'll throw that one to you.
We do have plans. We do have plans. Well, at the moment, we don't use it. We do have plans to use it, but we didn't in the past because we were using the on-prem version of Dremio based on our security requirements. So that wasn't available back when we first started. So that's why we went the route of DBT, using the DBT connector to manage all of our spaces and VDSs. So now that that's available on the on-premise version, it's something that we're definitely going to be looking at.
Awesome, thank you. And to make sure we get a variety of questions answered, I'm going to hop around here a little bit. Jumping to Ricardo's, his question is, from a cost saving perspective, where do you think you would have been spending the most time and probably money with that on if you didn't take the approach of using Dremio?
Yeah, good question. So let's think about what you would need, right? You would need to pull data from vastly different sources that aren't all straightforward. You need to get all of this stuff into a data lake and efficiently query it, shape it, change it, not lose the lineage, not lose the logging, do it at scale. And especially early on in startup days, you don't have a team of people to do that. You have one. And later on, you might have two. Later on, you might have a few more. So you have to think about, what would it take to get data from every possible source, put it in one place in a very efficient way, manipulate that data, and then make it predictably available to all types of downstream consumers. So depending on your type of data, depending on the rest of your stack, like, those could be very different answers. So, but as far as the cost savings goes, I mean, the time actually is more expensive than software cost when it comes down to it. So if you have 5 engineers working on something for 6 months, take their salary and divide it by 2, and that's the cost of 6 months of time, let alone the overhead of things like benefits, right? So yeah, I mean, there's a significant amount of cost saving just in the time of the velocity that a tool like Dremio buys you.
Great, thank you so much. Jumping around a bit more here, would love to, sorry, we've had some great questions. I want to make sure we're getting a variety of ones here. Let's jump to Peter's. Peter asked, what type of end user security data sensitivity methods are used to provide or prevent access to data?
Yeah, good question. So a lot of our product itself is, it's a different type of data consumer downstream, but through the data pipeline, we have to make sure that we respect the requirements of all of our various different customers. Some are just like, I want everything in ForceMetrics. You can search everything. Everyone using ForceMetrics can search everything. I want it all. Others control what we're able to get for legal reasons or policy reasons. They control what we're able to get, and then we only pull that in and we have a lesser view of their data. And then others, we get everything, but we can't put everything in the product. So in the middle sits all of this data flow stuff that we talked about, which is Dremio semantically representing that. So we have to actually utilize the clean layer and the standardized layer to make sure, well, and to a degree curated sometimes, to make sure that we're accounting for, is that specific record locked or sealed or expunged, or is there some other more complex logic that we have to account for to make it so that that particular row does not make it into anything downstream of it that is consuming it. But then the second part of that answer for that question would be, we're able to, even for something like interviews, we're able to do row level and column level manipulations to the data, and little asterisks, little ways of securing the actual values themselves, even in scenarios where you still need to provide people access to the entirety of the rest of the data. So there are a lot of different data sensitivity needs that come here, but yeah, I think that covers a few of them.
Yeah, and I'd also answered another question in the chat earlier, but we are end to end for all data processing of this data, the nature of the data. We are bound to the FBI CJIS requirements for processing and storing the data. So that's Criminal Justice Information Services. So they outline all the standards that we need to follow and that agencies have to follow themselves to actually store and process this data.
Awesome. Thank you both for that. All of that information, very helpful. Um, Wanted to open up another question from Ricardo. He was asking if you ever considered using some of Dremio's data federation features rather than doing, extract loads for real-time data sources.
Yeah, good question. So we had considered that upfront for a handful of different potential sources, but the easiest way to think about that in this space is that in order to query the data in place and do everything that we do to it, now what you're doing is you're actually pushing down the lift of doing that down from your compute to your customer's compute. So some of these systems are ancient. They're very old, where a select statement is like nearly the end of the world, right? So we get the data out of their system in the most lightweight possible way, which is sometimes a bit tedious, let alone it has to be continuous. And then we put that into a very, very scalable and efficient data lake. So that way we can do everything that we need to do with it, but without actually negatively impacting customer systems at all, especially if we're connected to a production system. Imagine we wrote some join wrong and it just ran away and it didn't cancel in time. Now we're usually not connected to a production system directly, but in that scenario, it would be possible that we would be. So imagine you write an otherwise innocent analytics query, or you plug in a Power BI or whatever, a Tableau dashboard to some analytics view of the data in Dremio, and you're effectively live querying it. And now you've taken down a 911 system for an entire city for an hour. That will be the last time that you ever interact with any data in this entire industry, right? So we're extremely cognizant of avoiding any potential for negative impact on customer systems in everything that we do.
Awesome. Thank you so much. That has been a lot of questions coming in. Really appreciate everyone continuing to populate them and staying on to hear these answers. We have probably two more for time, but just want to preface these final two questions with everyone should be receiving a copy of a recording of this webinar in your emails tomorrow. So if you missed any parts of this, don't worry, it's coming to you soon. And it will be live also on the Dremio website and YouTube channel later in the week as well. So don't feel like you need to get everything answered in the last 2 seconds if you might have missed a slide or two. Let's go ahead and answer Hanato's question here. Asking first, are data analytics tools like Tableau, Power BI, etc., also leveraged for that standard curated data that you guys mentioned earlier?
Yeah, so we have a lot of different data consumers, and one of them is exactly that. So you can actually plug all sorts of tools like those straight into Dremio and treat it otherwise as just like a database source, but it doesn't, the Dremio connectors for those tools don't technically know the difference. It's like, what's the name of the table? Really, it's a VDS in Dremio, virtual data set in Dremio. So yeah, we have different things that actually query VDSs directly and make it so that anytime you look at a dashboard or if you hit refresh on a dashboard or whatever, it always has the most up-to-date representation of that underlying data. And that's where the actual performance of Iceberg really comes in handy, because imagine you have a Power BI or Tableau dashboard that is querying every single customer of ours, and you open up the dashboard and it just loads in a millisecond and it's looking at 100 million or 200 million different rows per actual type of data and then joining them all together. The performance is pretty incredible. And that makes it so those sort of analytics tools aren't struggling to generate complex queries on the fly, because you can actually define that in a view, say in curated, of whatever example you could come up with. But let's say you made a view in curated, which is a very efficient query, and you can actually just point those BI tools straight at that curated view, and then they're not creating a giant SQL statement that they're trying to constantly execute on the fly. And then that opens the door to other levels of performance optimization that you could do. Like one of the features in Dremio is reflections. And think of reflections as on any given VDS, I could go and enable reflections and do very complex ones if I want. But the simple aggregation would be like this semantic representation of whichever data it's looking at, ignore the lineage. It could be 50 tables and 50 customers. It doesn't matter. That VDS, if I enable reflections on it, it effectively under the hood is more or less putting that VDS in a proactively but continuously updated Iceberg-like availability. So you're hitting the same performance as the actual Iceberg table directly, but you're hitting that when from a BI tool you're connected directly to a curated VDS that is otherwise rather complex, but now if you ever need to speed that up, Dremio enables you to do that in a number of ways, one of which is reflections.
Awesome. Thank you so much for that information. That was 12 questions answered in a good amount of time. So I want to go ahead and pause there and thank everyone for the amazing questions. Really, really great interaction here and appreciate it. And want to give a big thank you to both Brendan and Austin for their time today, explaining how ForceMetrics really is changing the landscape when it comes to first responder data and unlocking a lot of previously unavailable insights and efficiencies. So thank you all for your time today. We look forward to seeing you on future Gnarly Data Waves and other Dremio content. Just a heads up, this Thursday, we do have our predictions webinar for 2025 with several different leaders in the industry. So would love to see you there. Otherwise, thank you all.